I'm Terry Bucci from Ohio State University Math Literacy Initiative. We're doing a series for the remainder of the summer on critical areas of focus. As a state university in Ohio, we're going to be paralleling this work with the Ohio Department of Education's critical areas of focus. I'm going to show you how you can find that online. So, and if you're not from Ohio, your state may have a critical area of focus list as well, or you could use Ohio's. It's a great tool. So, let me just show you. So, if you just search for critical areas of focus in mathematics in Ohio, you come up with this. It tells a little bit about what it means. Just a short preview. Critical areas of focus are these big ideas for each grade level that students coming out of that grade level, we need to make sure that they have a really firm foundation on, so that when they go into the next grade level, they're like at grade level and being able to use what they've already learned. Math is very connected to other mathematics, so we want to make sure those connections are built in a strong way. So it tells you a little bit about what critical areas of focus are. It's primarily for teachers, but I'm thinking especially just because of this last spring when basically everyone was a teacher. I mean, we all are teachers anyway, but some of you just felt the joy of teaching your children for the first time this last spring, which I think is exciting, that you got to see what it's like to work with little ones, or maybe even big ones that don't really understand the things the way that we do. So how do we get students to believe in themselves enough to think about mathematics in the way that they think about mathematics? That's one of the real goals. They are the mathematicians. We don't want mathematics to be something like, I am this higher knower, I know math, so I will impose it on you. We don't want that. Math is personal. Like we need to have that personal connection to it. So for kindergarten, in each of the grades, K through 8, on Ohio Department of Education's website, you'll see these critical areas of focus. This is kindergarten. Kindergarten has 2, but they're 2 kind of big ones. So we have there, if you haven't seen it yet, there's a brief video on cardinality and counting. So take a look at that video if you'd like, if you haven't seen it. And then also within the same critical area of focus number 1, which in kindergarten is representation and comparing whole numbers. There's also within a subset of that first piece is also operations and algebraic thinking. So that's what we're going to talk about today very quickly, just to kind of give you an idea of what it means. So you can read what the document says. We'll talk a little bit more in like layman's terms. What does this mean? So for operations and algebraic thinking, again, this is kindergarten, and again, this is at the end of kindergarten. So if your child has gone through kindergarten and they're getting ready to go into first grade, these are the things that your first grade teacher really would like to have us spend a little bit more time with our students on, especially this summer because spring was a little bit kooky, and we want to make sure that they're getting off to the right foot. So let's dive into this with some activities then. So again, you can check out this site. It'll give you more of the specifics. If you look at more of those specifics and the site and have some questions about what it means or what kinds of activities could you use to hit such and such, please send us a message on the Math Literacy Initiative Facebook page or also on our Instagram page. Shoot us a message. And if there's something that you'd like in particular for us to talk about, we can do that as well. So we really are here to serve you and your students and our community. So let's talk a little bit about how we represent this operations and algebraic thinking component of kindergarten mathematics. So let's first talk about the beginning piece, which is being able to understand the combination of objects. Now, I've been trying throughout the course of these videos to use tools that are easy to find. Like, We don't all have counters at home. We don't all have the ability to go outside and get stones or whatever. So let's say you don't have those tools. You probably have some scrap paper somewhere. So I just made real quick counters out of rolled up scrap paper. Some of them are red, some of them are white, but these counters work just as well. And again, use the tool of many teachers, which is have your child make the counters. It'll get them invested in the activity, but it'll also take a little bit of hassle off of your hands because they're actually making the tools. It'll also give them some ownership on the task that they're about to do. So we want to be able to add and subtract within 10 using objects. So I'm just going to put, if I have this, and I'm going to just put some like there. All right. So the first thing we want to do, and we talked about this before, we have to know that our students can count the pink the pink balls, and they can count the white balls of paper, and that they know. Remember, we talked about cardinality. That they know that if they count these pink 1, 2, 3, 4, and they say 4, they know that there are 4 in that set. If they count these, first 1 to 1, remember touching each one, and they know that this is 3 in the set. So the question might be, all right, we have 3 white pieces of paper, we have 4 red pieces of paper. How many pieces of paper do we have all together? So how many red and white papers do we have all together? How would they go about doing that? So one of the things that you want, and again, these are kindergartners, so these are just ways that they act. So you want them to do their own action. They may, and quite possibly, will just smush them all together and then recount. It tells us a little bit more about what the students know if they start with, let's say, they push them together like this, and they start with the number 4. So we know that there are 4 pinks, and then say 5, 6, 7. That's what's called counting on. So if they can take one of the numbers, and it doesn't matter, it's most efficient for students to count on from the highest number. It doesn't mean they have to, though. If for whatever reason, 3 is their favorite number, happen to be mine, but if for whatever reason they start with the lower number, that's okay. It's not the most efficient, but that's how they see it, so let them do it. So counting on, again, can be that they recognize there's 4 reds, then they say 5, 6, 7, there are 7 pieces of paper. Again, that fact that the number 7 that they say, they know that tells you how many they are in this set. That's an important piece. That's called the cardinality. They could also start with the 3, so they know there are 3 white, 4, 5, 6, 7, and there are 7 pieces of paper. A really cool thing to do, because especially this is after kindergarten, is to ask them to do either way. Will there be the same numbers of pieces of paper if you start with the pink and then count on the white? Will that give you the same number as starting with the white and counting on the pink? So see my emotions, the way I question? It's kind of like, I don't know this. Maybe you could help me with this. Maybe you could help me understand that. We want to have that kind of a relationship, whether you're a teacher, a parent, a sibling, so that we're learning this math together. Math is way too often taught as a I know it, you don't hear, let me pour it in your brain. That's not how math works. That's not how we work with math. So we want to be able to figure it out on our own. So kind of play with your students a little bit and say, I don't know, what do you think? And ask them questions that way. So using tools and objects, this could be one way of using these objects. Another way could just be using a tool that's handy. Well, what's a tool that's handy? The tool on our hand. So I have this tool and I have this tool. Or I can just hold them up here. I have these tools. I can use these tools. There's absolutely nothing wrong with using these tools. It makes sense to use these tools. And it's super cool if you have 5 phalanges, fingers, thumbs. If you have 5 on each hand, it's super cool because it just happens to go with our base 10 system. So we can use these as well. So let's say I have 5 fingers held up on this hand and 3 on this hand. How many fingers do I have all together? Well, again, you can start by counting on. So counting on in this way, we could have this is 5, 6, 7, 8. We could count on that way. Or you could count on 3, 4, 5, 6, 7, 8. That is super cool. We ended on this hand one time and got 8, and ended on this time the other and got 8. And here's what you do with your kids. I wonder if that works every time. Will that work if we do like a 4 and a 2? Let's see if it works. Now, in your head, you know it works, but you're just like, it's that mystery that oh, I don't know, is that gonna work? And then they get into it. They get excited about seeing whether or not that works. So the way of using objects and solving problems, we can use tools that we have handy. We can use tools that we make. We can use just tally marks to see if something's, to find out what a solution for combining or removing would be. So this first idea is looking at objects. So I'm going to put down some more objects because we've really only talked about adding, putting things together. So now we have this number of objects and say, okay, I want you to have 8 objects, and I'd like you to tell me how many objects would be there if we removed 3 of them. So again, have them do the work. So have them show you the 8, and we're going to remove 3 of them. So 1, 2, 3. So what do we have now? Well, we're going to count what we have now, and we have these 5. So we have the 3 that we removed and the 5, and that's the 8. You can do it with hands too. So we have 8, however they want to do 8. They can do 5 and 4. They can do 4 and 4, whatever they want to do to get to the 8. We can do the 8, and then we can remove 3 of those, and we have what? 4. Maybe we could bounce that one over here. So do some playing around with it. So this is when the first part of this is doing operations orally and written, and we want to see if they can use counters or some other means of telling us that they know what the answer is. So another one is to solve actual problems. So solving problems within 10. So let's say we have a problem that's actually written in problem form. So we have these symbols. The first thing we have to do is make sure that we're calling these symbols the same thing. So you don't want to just slap down a problem like that and assume your kindergartner knows what this symbol is or what this symbol is. And if they don't, that doesn't mean they're lost to math forever. It just means they need to play with it a little bit more. So this symbol here, we're combining these numbers together, and that's what we just did with our counters. This symbol is much more complex. So I'm going to do a special session that's just on the symbol of that equal sign, because we make way too many assumptions about what students know or don't know about the meaning of that particular sign. But that'll be for another time. So if they have a written problem like this, 5 plus 3, we want them to be able to use or to solve this problem using objects or drawings. So we can use an object. So here's our 5. I'm going to add to that 3. So here's our 3. And what do we have then? Well, if they know what this symbol means, then they push them together. If they look at you kind of funny, say, then you'll need to have some conversations with them about what that symbol usually means, and just play around with it. Ask them what they think it means, and then go off of what they say to get them to a place where we know that this is a combination, or we're pushing these things together. So what would this be? This would be 8. 1, 2, 3, 4, 5, 6, 7, 8. We know it's 8. We can do it on our fingers. We can also draw pictures if it makes sense, or do tally marks. So if we have 5, 1, 2, 3, 4, 5, and we have 3, 1, 2, 3. Again, you can find out what your student feels comfortable with by knowing if they start off knowing this is 5 and say 6, 7, 8. That tells you they know how to count on. If they count 1, 2, 3, 4, 5, 6, 7, 8, that's still fine. That means they still know that the idea behind this symbol is to combine these things. And then because of the first critical areas of focus, we know that they know how to write the numeral 8, so they can solve it that way. All right, so these have all been addition problems so far. So let's talk a little bit about subtraction problems. And we're going to talk about subtraction in terms of removal first. So within 10, so let's say we have the number 9, and we want to remove 3. So again, don't make assumptions about symbols. We're going to talk about this as remove. Again, this is a biggie we're going to talk about in its own session. But we can do these too. So we want students to be able to, within 10, both do addition and subtraction problems within 10. They have to be able to understand how to work with these things when they get into first grade, because once they get into first grade, they're going to start using it all over the place. So 9 minus 3, so we're going to have 9. So again, have your child or the student count out the 9. Don't do it for them. You might know, and you can learn a lot from your students by watching how they count out their 9. They may just do it one by one. I don't know if you've noticed, but I just did mine in sets of 3. So that tells you a little bit about what your students know and don't know. So here's our 9. So we have our 9, and we're going to subtract. Some teachers say take away. There's nothing wrong with the word take away. Some say to remove. We're going to also talk about this idea of comparison. So we have 9. We're going to remove 3. So I'm going to take 1, 2, 3. And what do we have now? What is that? What do we have here? 1, 2, 3, 4, 5, 6. And we know that we want our students to be able to represent that number 6 in a numerical fashion. So again, you can do it with tools. You can do it with tallies. They will get to a point when they just know these sets, particularly in addition. Subtraction's a little bit different, but we'll talk a little bit more about that. So this is another piece of this critical area of focus that we know our students have to be comfortable with when they get to first grade. The next thing is decomposing numbers. I'm going to write that down. Decomposing. So we're going to decompose numbers that are between 1 and 10. So for this particular task with kindergarten, we want students to be able to decompose numbers up to 10. So what does it mean to decompose a number? So I'm going to use stones again. So I have 2, 4, 6, and 8. Here's 9 and 10, just so I have the 10 already set out. So we have 2, 4, 6, 8, 10. So let's say we have the number, I'm going to just grab a few of them here. So we have this number, and we'll ask our student, what is this number? This number just happens to be 7. So we have this number 7. We want to decompose it. Well, what does that mean, and why do we care? Decompose it means to look at this number 7. These are off to the side. I'm just going to keep them there because that's our set of 10. But to decompose the number 7 means to look at it and make all the different arrangements that you can. Now, first of all, I would suggest that you make a couple of piles. Say, okay, we have this number 7. How can we break this number 7 up into 2 other numbers? Or how could we count it and make 2 piles? Well, and it doesn't matter. Really, all you're doing right now is showing your students, or they're playing with these numbers to show themselves, that 7 can be broken up into what? A 3 and a 3 and a 4. So 7 can be a 3 and a 4. That makes sense. Does that work? Well, it'll work if we count them up and make sure it still makes 7. Now, yes, you and I know it still makes 7, but let your student count it up to prove to you, I got it, it makes 7. And then let's say, okay, I wonder if we could make any other sets like this. Let's see if we could. So let's try again. I have this number 7. So we already know that we broke it up to 4 and 3. We want to break it up again. So let's see how many other partners we can get that can give us 7. I think I can find a partner. I'll find a partner that goes with 2. So I know all of these have to go over here. What's 2's partner for 7? Well, we have 2 here, and then we have 1, 2, 3, 4, 5. So 2's partner, when it comes to 7, 2's partner is 5. 2 and 5 go together to make 7. And go together might look like this. So this notation, if you did this activity with me, it would make sense, right? We know there's a 7 and here's 2 partners that make up 7. We also know the one that we did before. I believe it was a 3 and a 4. We know those make up 7. Now you might be thinking, oh my goodness, why isn't she putting a plus there? Why isn't she putting an equals here? All we're doing right now is just playing with numbers. We're just decomposing and composing numbers. That's all we're doing. Let them play. Let them play with it. Okay, can you think of any other sets? Well, I'm going to put a 6 here and a 1 there. So what do we know? We also know that 7 can be decomposed into a 1 and a, what do we have here? Of course you know what we have here, but you want them to count it. And the 6, that's a partner. That's a partner for 7. So when we talk about decomposing numbers, and we want, your students need to, by the end of kindergarten and to be prepared for first grade, they need to be able to decompose and compose numbers up to 10. So we were decomposing. You can also compose, but decomposing is the one that we really want to focus on between 0 and 10. So there are all different kinds of ways. Eventually when you're talking to your students, and they may even say, but I know how to do this one. Excuse me. And if they know how to write that numerical expression, go ahead and let them write it. It's not as if they have to stick with this, but they need to know that it's okay. That it's their notation for representing 7 can look like this if we're working together, because we have this kind of generated language that we've used together, and from now on we can use this generated language. Now when they get into first grade, the language will most likely look like this, but let them play with them. Let them be the mathematician and invent their own symbols. It makes sense. So that's another piece for this particular critical area of focus. One other one is, I'm going to use one of my favorite tools, which is this egg crate. So I have this egg crate. Oops, doodle. I cut off the end too, so we have it's called a 10 frame. The other really important piece, this is incredibly important for kindergarten, is making 10s. And making 10s, we want our students to be able to close their eyes and see a 10. So if I close my eyes and I think of the number 10, I see the numerals. I see a 1 and a 0. That's what I see when I close my eyes. But that's because I'm old. Right? I've done this stuff for a long time. Your students are just at the beginning of their math, of their math learning, and so when they close their eyes and think of 10, they might not necessarily have that 1 and 0 in their head. They might. You want that, but you want them to see something. So let's say they close their eyes and they think of their 2 hands together. That's how they think of their 10. So they can think of it. Okay, I know I have my 2 hands. I have my 10. That's my 10. All right. You could also use this tool so often, and this is one of the ways that a lot of people get to their 10 partners. They could use this tool so often that when they see it, they see 2 rows of 5, or if you're using it this way, 5 rows of 2. This is automatically set up in what's called an array. So if they have, let's say we want them to find 10s, and finding 10s and having this as a daily activity for your child at home would really, really help them in their math class if they're either going into kindergarten, coming out of kindergarten, or going into first grade. Now, if you happen to have a die from a game that you have around, use a die and then have them put it in and find out what the partner number to 1 would be. That means what and 1 would fill up our whole tray. And talk about it like that first. What would fill up our whole tray? And then start talking about, what does our tray represent? Well, our tray represents 10. Don't start there though. Filling up a tray is our first task. Or having all of our fingers up. If we start with 1, how many more digits, finger digits, do we have to put up to get all of our 10? So we want them to start thinking about, if I have 1 finger up, I know all the rest of them are 9. Now they're not going to know that automatically, but we're going to do it so many times that they know that a 4 goes with a 6, that they know that a 5 goes with a 5, that they know that a 3 goes with a 5 and these 2, 7, that it gets to what's called an automaticity. And you want them to get to that automaticity. Let's say you don't have any die at home, but you still want to play this game with your student. Have them, don't you do it, you have the student write the number. So, because they have to know this for first grade anyway. So let's have the student write all the numbers from 0 all the way to 9. So I skipped over some. But have them write the number. You don't have any die, have them fold up the number, and there they go. There's their game that they can do, their making tens game with. It can be something that you just have that's off on the side of the kitchen, so that if they're in the kitchen, we can just pull this game out whenever they want, and they pull a number. My number is 8. All right, that means I have to know the 10 partner to 8. So if you want, if your child has already been through kindergarten, just have them take a guess. What do you think it is? What's that 10 partner to 8? And have them just write it down, whatever they think of. And it's okay if they don't get it right automatically. But then let them play with it. Okay, let's play. So if we have 8, now I'm going to do my 8s as 2 sets of 4. What's that partner? What do we need to fill in that 10 tray, or the 10 tray, or the 10 frame, however, whatever you want to call it. So just keep doing this over and over and over. Huge, huge value for your child or your student if they can automatically name those partners of 10. And that's called making 10. Incredibly important for when they get into first grade and the end of kindergarten. So the last thing is to be able to fluently add up to 5. So this is for kindergarten. Now, you might be saying, but we've been working with 10 this whole time. What the heck? Why are you changing it to 5 now? And it's because this particular standard uses the word fluently. Fluently means with automaticity. That means they can just name it because they've seen it so many times. They don't have to use their fingers. They don't have to use the counters. They just know it. Now, if your student is still using their fingers or counters, that's okay. You just need to keep pushing them and doing it more and more and more so that when they get to that point of fluency, they can do it, right? So we do want them, before they enter first grade, to be able to know their addition and subtraction problems within 5 automatically. And that's another reason why having something that looks familiar, a hand that looks familiar, that they can just close their eyes and they can visualize what it looks like. So if they see something like this, 2 plus 1 equals, what they see is either, when they close their eyes, they see these 2 fingers, and then they have this 1 and they know what that 3 is, so that they know when they have 2 and 1 more, it's not quite 5, it's 3. So we want them to be able to either see fingers, see their base 10 tool or their making 10 tool, or something else. We know that we want them to have. They could also, in this particular case, because we talked about this for the other critical area of focus, they know that this is 1 more. This is the 1 more idea. So they may, in their mind, be thinking of this as a number line. 1, 2, 3, 4, and 5. So they may also be thinking in terms of what we talked about in the last session, which is if I have 2 and I have 1 more, then that's the next number in our sequence, and that's the number 3. So all of these different ways, we want them to have so many experiences with all these different ways so that they can just come up with it. But in kindergarten, they need to know all of those. So they need to know what 1 plus 4 is. They need to know what 1 plus 3 is, 1 plus 2, 1 plus 1, and 1 plus 0. They need to know all of those. So notice how I wrote these down. We're using a pattern here. And whenever you use patterns with your students, it's helpful to them too. So we started with 1 and we did all the different combinations with 1 that gets us up to a maximum of 5. So now we can do the same thing, 2 plus 2 plus, so 2 plus what gives us 5? Well, I'm going to think about my fingers, my hands, and I know if I have 2, I know there's these other 3 that gives us this 5. So I'm going to visualize that one because that's just how I know it automatically. So, but then I'm going to do some of the other ones too. And we know we have to have less than 5, so as a sum. Sum is the answer to an addition problem. So going up through these. Now, it might be kind of fun with your child to write these patterns together. It doesn't mean you do it and you say, then you do this, then you do this, then you do this. That is not fun. It is not fun for anyone. I love math, and I don't like it when someone tells me how I have to solve it. So let them have fun with it. Let them play with it. But this is that second piece of the first critical areas of focus, which is representing and comparing whole numbers. There's one last piece to it that I'm going to do in a little bit today, and then tomorrow we're going to do the second critical areas of focus, or critical area of focus for kindergarten. So again, thanks for tuning in. If you have any questions, please post them on our Facebook page, our Instagram page. Go to our YouTube channel. There are some other videos that might be of interest to you, and have fun with your students this summer with math, getting them ready for next year. Have a great day. Go Bucks.